The L-function can be obtained by the subordinate zeta function of mod 5, by the binomial theorem of the zeta function, and the L-function can be inverted by the functional equation of the analytic continuation. Since the functional equation of the L-function exists only for the primitive Dirichlet character, only the L-function of the primitive Dirichlet character can be inverted. In addition, the gamma function and trigonometric function of the inverted L-function are again eliminated by the inversion of the gamma function and expanded into the negative zeta function. The Dirichlet character chi1, chi2, and chi3 of mod 5 are primitive characters, and chi1 and chi3 are odd characters and are symmetrical to each other. Chi1 is the subordinate zeta functions 5, 1 plus 5, 2, I minus 5, 3, I minus 5, 4, and chi3 is the subordinate zeta functions 5, 1 minus 5, 2, I plus 5, 3, I minus 5, 4. Chi2 is an even character, and the subordinate zeta functions 5, 1 minus 5, 2 minus 5, 3, plus 5, 4. The sum and alternating sum of the subordinate zeta functions 5, 1 and 5, 4 cancel each other, and the sum and alternating sum of the subordinate zeta functions 5, 2 and 5, 3 cancel each other, so the odd character expands into a negative odd zeta function, and the even character expands into a negative even zeta function. The L-function inversion of odd characters is symmetrical, like the L-function inversion of mod 3. But the L-function inversion of even character is in the form of minus 2/5 to the s power plus 2/5 to the power of 2k plus 1. But the cosine of the gamma function inversion and the negative even zeta function add 2 to the s power, 1 minus 2 to the power of s minus 1, 1 minus 2 to the power of the 2k minus s, over 2 to the s power into the term of minus 2/5 to the s power. Due to the trivial zeros of the zeta function, odd characters become trivial zeros at negative odd numbers, and even character becomes trivial zeros at negative even numbers. The infinite sum of the expansion of the negative zeta function is the same as the L-function value at negative even numbers of odd characters, and the same as the L-function value at negative odd numbers of even character. The L-function inversion of mod 5 is established in all domains, and although the L-function of natural numbers corresponding to the trivial zeros cannot be obtained by the pole of the zeta function at s equals 1, the L-function value for natural numbers such as the functional equation can be obtained. The inversion of the gamma function can obtain the reciprocal gamma function by the asymptotic equation of the trigonometric function and the zeta function pole, but the asymptotic equation of the zeta function pole does not hold in the inversion of the L-function. However, the convergence value of the L-function of the odd characters for even numbers and the L-function of the even character for odd numbers can be obtained by the inversion of the L-function. The exact L-function value can be obtained by the Gauss sum as shown in the published Riemann hypothesis. The L-function value by the Gauss sum is also a negative zeta function expansion, but it is not the same as the inversion of the L-function. By inversion of the L-function of mod 5, the non-trivial zeros of the critical line can be obtained, and it is confirmed that it is the same as calculating the non-trivial zeros of L-function of mod 5. The L-function obtained by the subordinate zeta function of mod 5 and the inversion of the L-function are the same for more than 8 decimal places. The negative zeta function term of the L-function inversion, minus 2/5 to the s power plus 2/5 to the power of 2k, does not create non-trivial zeros, but it creates non-trivial zeros by multiplying with the alternating sum of negative zeta function. This is comparable to the inversion of the gamma function. The inversion of the L-function of mod 5 can only be represented as an alternating sum of negative odd zeta function for odd characters, and as an alternating sum of negative even zeta function for even character. Therefore, the non-trivial zeros of the inversion of the L-function is created by the symmetry of the alternating sum of negative odd zeta function and the alternating sum of negative even zeta function.